welcome back to another lecture from organic chemistry. And until now, we know that whenever we have a carbon with 4 different substituents, that carbon, it will be stereocenter. Okay, and if there is a stereocenter, there is a chance that our molecule might be chiral. Okay, might be chiral. Okay, I have to say this one. Okay, sometimes we have molecules that they do not have a stereocenter, but still they are chiral. Still they are chiral, and we will talk about them at the end of this chapter. But for now, okay, we're going to go after the stereocenter, see whether we have a stereocenter or not, whether our molecule is chiral or not. Okay, and this is the carbon that I'm talking about. That carbon is seeing chlorine. There is hydrogen at the back. Okay, so we have hydrogen in the back of the molecule. What else? We have CH2 on the left and CH2 on the right side. And again, CH2, CH2. So this carbon is filling same arms or same substituent on both sides. And because those two substituents are identical, and in this case, I'm going to say, no, we don't have a stereocenter. So the answer for first question is going to be no. Is there any chance that our molecule will be chiral? Okay. No, the answer is going to be no. What's the reason for it? If you can find a plane, okay, plane of symmetry. And what's a plane of symmetry? If you can chop the molecule to 2 halves, identical halves, in that case, we say the molecule is not chiral. And do I have a plane here? Yes, I can chop it to 2 halves, and this is going to be 1/2 of the molecule. Okay, that's going to be half of the molecule, and now this one, it will be the second half of the molecule. Okay, so I managed to chop the molecule to 2 halves, and in that case, I'm going to say, because we have a plane of symmetry, so this is a sigma. Okay, sigma is a plane in symmetry, plane symmetry. So I'm going to say no, our molecule cannot be chiral because of the plane symmetry. Another example. Okay, we have 2 substituents, 2 chlorines, and they are 1, 3, 3. They are sitting on first and the third carbon, or we have 2 OHs. And on the first example, we have a chlorine is pointing down, and this one also pointing down. Can I find a plane of symmetry? Yes, I do have a plane of symmetry. Let's show it. This is the plane of symmetry. I can chop the molecule to 2 halves, and it will mirror the hydrogen to each other, and also chlorine as well. Okay. Do we have a stereocenters? Let's check. Okay, let's check whether we have a stereocenter or not. Okay, so this carbon number 1 is sensing hydrogen, chlorine, and what else? CH2 here, CH2 there. Okay, let's keep continuing, searching. When we move to the right side here down, we see CH2. But if I move in this direction, I see carbon with chlorine attached to it. So those two are not identical. Okay, because they are not identical, there is a stereocenter. There is a stereocenter there. And yeah, you can use the same logic here. Okay, if you move in this direction, after first carbon, then they are identical. Okay. In the second carbon, if you move counterclockwise, you see chlorine, and if you move clockwise, you see only CH2. And because they are different, that carbon also will be a stereocenter. So we do have a stereocenters. And answer for this one is going to be yes. Okay. Do you have a plane of symmetry? In this case, yes, we have a plane of symmetry. Okay, and that plane of the symmetry will make the molecule non-chiral. Or A. Just simply, you put A, and you say achiral. That means non-chiral. Okay, how about the second example? Second example, OH is pointing up, and that OH also is pointing up. So we are dealing with cis isomer, and left side also was cis isomer. And can I find a plane of symmetry? Yes, plane of symmetry is there. Do we have stereocenters? Yes, one stereocenter is here, and that's going to be a stereocenter there. So we have 2 of them. And the molecule even has 2 stereocenters, okay, and those are the stereocenters. I'm going to put star on them. We have 2 stereocenters, but it still is not chiral. Why? Because of plane of symmetry. If you have a molecule that does have stereocenter, but is not chiral, okay, it's not chiral because of plane of symmetry, the name for it is going to be this. We use meso, okay? So our molecules, instead of saying achiral, we're going to call it, this time we're going to call it meso. Okay, so when do I, okay, forgive me, meso. When can I say meso? Okay, I'm going to say the molecule has stereocenters. Okay, stereocenters, but because of the plane of symmetry, it's not chiral. So in that case, we use meso for it. Okay, another one. We have OH is pointing up, OH there is pointing down. So this is going to be a trans isomer. Okay. And because it's a trans and isomer, I'm not going to have a plane of symmetry. So I cannot just simply chop the molecule to two halves, because when I mirror OH, I'm not going to see OH there. Okay. Remember, this OH is pointing up, that OH is pointing down. So we see those. We see like one OH up and one OH down. When you mirror my right hand, when you mirror it, you're supposed to see OH here. I don't see OH. I see OH down. Okay. And so there is, there is no mirror of OH on the left side. And because we don't have a plane of symmetry. So I'm going to say, do we have a stereocenter? Yes, our molecule does have a stereocenter, and it has actually two of them. Okay, so I'm going to say the molecule has two stereocenters, and because there is no plane of symmetry, and the molecule will be chiral. Okay. Next one, it will be the inversion center. What's the inversion center? Okay, can I find a plane of symmetry? Let's see. Okay, if I put a plane of symmetry here, okay, I expect to see nitrogen in this distance from it, but I see oxygen. And if I mirror the oxygen, and I'm supposed to see oxygen here, I see nitrogen. Okay, you might say, why don't you put the mirror here? Okay, let's put the mirror here. If you put the mirror there, in that case, okay, when you measure the distance of oxygen from the mirror, you're supposed to see oxygen there, but you see nitrogen. And same story there. Okay, so clearly we don't have a mirror there. And again, you might say, why don't you try that one? Okay, and if you try that one, okay, and see what will happen in that case. In that case, okay, I see nitrogen here, this distance, and I see carbon there. Okay, so those two are not really mirrored, like identical. And you might say, oh, oxygen is fine. Yes, oxygen is fine, but then you have nitrogen here, and that one is carbon. So that's going to be the issue. Those two are not really mirrored. And so again, we don't have a plane of symmetry. So you might say, oh, that's chiral. You need to check one thing more. And okay, there is a place somewhere inside the center of the molecule. Okay, let me show it by here. There's a place inside the molecule that is connecting those two nitrogen. Okay, and also it's connecting oxygen, and it's connecting the carbons as well. Okay, and what's that center? That center, we call it I. I is the inversion center. Okay, inversion center, and an identical position from like that center, and you're gonna find a nitrogen cross of it. And same story for so for oxygen. If you measure this distance and keep moving that direction, you will see another oxygen. And last one, if you measure this distance, you will see carbon here. So we have an inversion center, and that inversion center will cancel the chirality. So if your molecule has an inversion center, molecule will be non-chiral. So if there is an inversion center, then the molecule will be achiral. Be careful. Okay. And let's check this molecule. Okay. And if I look the molecule from this direction and try to present the Newman projection for it, I see one fluorine here down, and another fluorine is going to be somewhere there. Okay. On the right side, when I look to fluorine, which fluorine? This one. Okay. When I looked at it on the right side, I'm going to see bromine. So I'm going to put the bromines here. The bromine, I'm going to put it here. And my left hand, I'm going to see iodine. Okay. And if you look between fluorine and bromine, you're going to see this iodine. Where is it between bromine and fluorine? So here you need to have iodine, and I'm going to put that iodine. Which iodine? Let's call this one number 2. Good. So iodine number 2, it will be back. And where is it going to be? Bromine. Bromine number 2, it will be here. And of course, that's going to be a fluorine number 2. Okay. Now, as you look, always 180 degrees from the first fluorine or first atom, you can find another fluorine or identical element. Okay, so if you look at fluorine number 1, 180 degrees from it, we have another fluorine. Same thing with iodine or bromine. Okay, and I can see a bromine 180 degree far from it, and last one I can see iodine. And in that case, we say we have inversion center. We do have, okay, sorry, yes, we have inversion center. We have inversion center. We do have two stereo centers. There is no mirror image, okay? There is no mirror image, but because we have inversion center, the molecule will be non-chiral, okay? So this is gonna be our inversion center, and even we have two chirality center, molecule, it will be non-chiral. Okay, how about those two? Okay, this is going to be up. That one is up. Okay, and first one is axial up. First one is equatorial. Okay, equatorial up, and the second one is going to be axial up. Okay, if I want to show them, I'm going to draw one. Okay. I'm going to draw one OH. There's a one bromine up, and the second bromine is going to be here. Again, it's going to be up. So these two are in cis position. Can I find a plane of symmetry? Yes, you can put a plane of symmetry here. And this molecule, even it has two stereo center, because of the plane symmetry, the molecule will be meso. It will be achiral. Okay, so it does have a stereo center, but it's not chiral. It will be meso. How about next one? Next one, we have this one axial up. That one is axial down. So I go one bromine, let's put it up, one is down. Then we say bromine, bromine. Okay. And do I have a stereo center? No. Do I have inversion center? Forgive me. Do I have a plane symmetry? No, there is no plane symmetry. Do I have stereo centers? Yes, I have two stereo centers. One is here, and that's the second stereo center. And so this molecule will be chiral. Okay. That molecule is going to be chiral. Next. How about this? Do we have a stereo center? That's the first thing that you need to ask yourself. Do I have a stereo center? Okay, you might say, yes, there is a stereo center. One is here and one is there. And the answer is going to be no. No, we don't have a stereo center. Why we don't have a stereo center? Okay, start from one side. Okay, it doesn't matter which side you start. Okay, let's start, for example, from this carbon and move this direction. Those two are identical. Here, again, they are identical until you reach this carbon. So from any side you start, always you have identical substituent attached to carbon number one. And because they are identical, this molecule does not have stereo center. So no stereo centers. Okay, we have one bromine is up, and the second bromine is down, and there are four carbons far from each other. What do we have here? We have inversion center. That's okay. I need to draw it better. If you connect these two, this is going to be I, or the inversion center. So this molecule, it will be achiral. Okay. More examples. We have this one axial up. Okay, so one here is up, and that one also up. Okay, can I find a plane of symmetry? And yes, where is the plane of symmetry? Okay, the plane of the symmetry, it will be here. Okay, and or I could maybe actually put them in better position so you can see them better. Let's put one here and one there. In that case, the plane is going to be somewhere here. That's going to be the plane. And this is going to be cis. Okay, do we have a stereo centers? Okay, yes, one stereo center is here, and that's going to be second stereo center. Why? Because if you start from here, okay, after two carbons, one here, two, after two carbons, you will reach this stereo center. And if you start from this direction, you go 1, 2, 3, and the fourth one after four carbon. Technically, the fourth carbon is the one with the bromine, and so they are not identical. We do have two stereo centers. Here you go, two stereo center. Do I have plane of symmetry? Yes. So this structure is going to be meso. Okay. Next one, and we have bromines in 1, 3 position from and far from each other. So one bromine, we're gonna put it here, and it's pointing up, and this one is gonna be equatorial. And is it up or down? Let's figure it. Okay, if this one is up, next one will be down. and this is going to be next axial position. The third one, it will be here. So this is going to be the axial position, and it's pointing up. So that means that this one, it will be pointing down. Okay, so bromine, it will be here, down. Can I find plane of symmetry? No, there is no plane of symmetry. Do I have inversion center? No, I don't have inversion center. Why don't, like, how come we don't have inversion center? Because if you have inversion center there, you're supposed to see bromine here. Okay, and that's going to be the inversion center, and I don't see it. Okay, do I have a plane of symmetry? If you put the plane of symmetry here, it will mirror bromine in this position. Bromine should be pointing up. Okay, should be pointing up, and I don't see it. So there's no inversion center, there is no mirror and plane symmetry, but we do have chiral centers. So this molecule, it will be trans and is chiral.